All right, welcome to today's Deep Tech Explainer. We're taking a highly professional, totally uncompromising, and honestly kind of ironic look at high-performance espresso systems in 2026. We're putting fully automatic and semi-automatic architectures under the microscope to explore the precise physics of extraction, the brutal reality of fluid dynamics, and the hilarious contradictions of modern smart home appliances. Forget your basic morning routine. We are about to treat coffee with the engineering rigor it absolutely deserves. It sounds like a total paradox, right? Is a quote-unquote dumb, purely mechanical coffee machine actually the smartest piece of tech you can put in your kitchen right now? In an era where even our fridges demand firmware updates, this kind of challenges everything we assume about progress. So, okay, let's dive into this and figure out exactly why tech geeks are reverting to mechanical switches. Here's our roadmap for today. First, the perfect extraction science. Second, thermal and fluid dynamics. Third, regional engineering philosophies. Then, the smart home paradox. And finally, future-proofing your brew. Let's get into it. Kicking things off with Section 1, the perfect extraction science, thermodynamics and fluid dynamics. Now, before we even think about touching a digital display, we've got to respect the unyielding physics of coffee. I mean, you essentially have to act like a fluid dynamics engineer here. It all starts with extraction yield, or EY, and total dissolved solids, TDS. Listen, this isn't just about taste. It's a strict mathematical relationship that defines the whole extraction process, relying entirely on the precise ratio of beverage mass to dry coffee mass, right according to the Specialty Coffee Association Brewing Core standards. If you don't control these variables, you're not making espresso. You're literally just randomly running hot water through organic matter and praying for the best. Just 0.5 degrees Celsius. Half a degree. In the world of high-performance espresso, this tiny, tiny margin is absolutely everything. If your water temperature varies by more than half a degree, it catastrophically alters organic acid degradation during extraction. Miss that thermal target, and your perfectly roasted beans will instantly turn overwhelmingly sour or horribly bitter. No pressure, right? Moving right along to Section 2, Thermal and Fluid Dynamics, Hardware Architectures. So, we've got a tale of two heating philosophies here. On the fully automatic side, you have thermoblocks and thermocoils. These use flash heating, basically forcing water through this crazy metallic labyrinth for a super rapid heat up. It's fast, yeah, but it's volatile. Contrast that with the mad scientist precision of a dual boiler equipped with a PID, that's a proportional integral derivative controller, which is standard in high-end semi-automatics. With this, you have dedicated boilers for your brew water and your steam, ensuring absolutely zero thermal interference. The PID uses these incredibly complex algorithms to actively hunt and lock onto an exact target temperature, constantly tweaking heating elements just to protect your organic acid degradation. It's brilliant.
And you know, this fundamental divide extends to how we actually move the water, too. Fully automatic systems overwhelmingly rely on vibratory pumps. They're loud, and they deliver this static 15-bar pressure that physically has to be mechanically choked down to 9 bar using an overpressure valve. Now compare that brute force restriction to the elegant commercial-grade rotary vane pumps you find in semi-automatics. We're talking immediate pressure ramp-up, whisper-quiet operation, and they're direct plumbed. Seriously, it is literally the difference between muffling a lawnmower and driving a luxury EV.
Now, let's look at the actual flow rate, designated as Q. This depends on the pressure differential and the hydraulic resistance of your compressed coffee puck. To prevent channeling, which is where water aggressively blasts holes right through your coffee, we use a process called pre-infusion. Now, with a fully automatic machine, you get a hard-coded, non-adjustable timed pause. It's just a rigid factory-set guess. But a high-end semi-automatic, that lets you manually program a low-pressure saturation of the puck. You actually get to control the fluid dynamics to prevent channeling like a true artisan, rather than, trusting a line of code written 5 years ago. Okay, Section 3. Regional Engineering Philosophies. Europe versus the Americas and Oceania. It turns out that different parts of the world approach these exact same fluid dynamics problems in entirely different ways. European powerhouses like La Marzocco and Jura, they really emphasize proprietary brew group designs, component longevity, and localized servicing. They prioritize intense internal fluid hygiene using some incredibly cool physics like Venturi effect milk siphons for automated frothing. On the flip side, the Americas and Oceania, championed by brands like Breville, are pushing this prosumer hybrid focus. They're aggressively innovating rapid thermocoil efficiency and highly digital user interface design, really trying to bridge the gap between semi-automatic control and digital convenience.
Which brings us to Section 4, the Smart Home Paradox, Closed Ecosystems.
All right, this is where flawless hardware engineering collides violently with the absolute nightmare of 2026 smart home networks. You bring a state-of-the-art appliance home and suddenly, boom, your Wi-Fi 7 or Asus mesh network is facing compatibility issues. Why? Because manufacturers insist on deploying these closed ecosystems with proprietary apps like LG Think or Home Connect. Honestly, these apps act like toxic relationships. They completely block open integration and flat out refuse to talk to centralized hubs like Samsung SmartThings or Google Home. You try a simple voice command to trigger a brew profile, and instead of coffee, you get an API execution error.
I want you to really absorb this fact from the source data. Quote, assigning complex state change commands routinely fails or returns API execution errors due to locked protocols. Think about the sheer irony here. We've got machines with absolute thermodynamic stability, utilizing PID controllers that hold water to a fraction of a degree, and they're rendered completely useless because a locked cloud protocol refuses to shake hands with your router. You can't make this stuff up.
Let's move to our final section, Section 5, Future-Proofing Your Brew, the Selection Matrix.
So how do we escape this madness? Well, we look at the ultimate selection matrix. Grind quality and extraction control absolutely go to the semi-automatic machine because of its standalone grinder and manual input capabilities. But here's the crucial twist: network automation. Counterintuitively, the analog semi-automatic actually ranks higher for smart automation than the fully digital automatic machine. Why? Because the semi relies on smart plugs and open home assistant relays, while the fully automatic is trapped in those locked cloud apps we just talked about. Not to mention, the semi uses standardized commercial parts for longevity, whereas the fully automatic relies on expensive proprietary circuit boards that are frankly doomed to fail.
And this right here is the ultimate 2026 smart home hack for Espresso. Step 1, buy a high-grade semi-automatic machine, specifically one with quote-unquote dumb, tactile mechanical switches. Step 2, plug that absolute masterpiece of fluid dynamics into a basic $20 smart plug. Step 3, use Android-based local automation like Tasker, HTTP requests, or Home Assistant to schedule your 1500-watt warm-up routine for, say, 6 a.m. And Step 4, you sip your perfectly extracted espresso with zero latency, having completely bypassed billion-dollar, heavily flawed, closed-loop software ecosystems. It's genius.
Because here is the tragic flaw of the fully automatic machine in the modern era. Since they use soft-touch digital switches, they physically cannot be automated via an external smart plug. If you cut the power and turn it back on, a digital switch just defaults to off. That single hardware choice heavily favors a closed-loop cloud and locks you, the user, entirely out of robust, physical local automation. Which leaves us with this final, kind of provocative question. In a fully automated, digitally connected world, who is really in control of your coffee? Is it you, dictating the pressure differential and maximizing your extraction yield? Or is it a server 3,000 miles away that just decided to update its terms of service? You know, sometimes the absolute smartest way to future-proof your home is to just embrace the brilliance of dumb mechanical perfection. Take control over your own extraction variables. Thanks for joining me on this deep dive explainer. Stay curious, and I'll catch you on the next one.